and welcome to this week's Convex Conversation with me, journalist Helen. Today I'm in Kew in West London to meet the Director of Engineering Design for McLaren Automotive, Dan Parry-Williams. McLaren was founded in 1963 by New Zealand-born racing driver, car designer and inventor Bruce McLaren, who achieved the British company's first Grand Prix win in 1968. Racing-wise, the company's history is rich with legendary cars and drivers, including James Hunt, Ayrton Senna, Fernando Alonso, Niki Lauda and Alain Prost. And Lewis Hamilton, of course, started his professional Formula One career with McLaren. But in the early 90s, they branched out into road cars, and the first, the McLaren F1, with a top speed of 242 miles an hour, was born. Dan, it's absolutely lovely to meet you. You have an enviable job title, Director of Engineering Design for McLaren Automotive. Tell me a bit about your role and what you do.
Okay, well, it's nice to meet you too, Helen. And I guess I would say the main part of my role is to try and define the concept and the architecture for new McLaren supercars in a nutshell. Obviously, that involves quite a lot more things than that. And there's a lot of people also involved in developing supercars and not just me. But I am lucky enough to be able to see the process from beginning to end. And the end part is also a great fun part of my job, which is testing and evaluating the cars and checking in that we're meeting all of our objectives and the cars end up being the way we wanted them to turn out in the first place.
With design in the title, are there some people who perhaps think your role is more about the shape and the look of the car as opposed to the engineering side of it?
That's true. It does cause a certain amount of confusion. In the car industry, there are different sorts of designers. In fact, in any industry, there are different sorts of designers. There are the sort of designers who concentrate on the aesthetics, and they are sometimes in my industry unkindly referred to as felt-tip fairies, but I would never do that.
Never on a podcast.
And then there are other kinds of designers who are concerned with I use the word architecture, but the structure and the functioning of the vehicle. For example, race cars all had designers design them, but they didn't go anywhere near a design studio. So there's quite a broad range of design, and of course they're complex products. And of course, nowadays we also have to include software, and we have software designers, and the virtual world of ones and noughts is just as important as the hardware these days.
So where does your bit come in? Which is the part that you are absolutely key for?
We start with what we call the attributes of the car. We define those in quite a lot of detail with quite a lot of granularity so that we can pitch a product against its competitors in the marketplace and make sure that it sits in the right place relative to other McLaren products as well. Those attributes turn into concept designs, choices of specification of different aspects of the car in terms of its powertrain, its structure, aerodynamic, those kind of things. And then that resolves itself into 3D geometry. Everything's designed in CAD, obviously, these days. And every aspect of the vehicle is modeled in three-dimensional space. And once you have all that completed, you have your car. It's just a matter of getting those bits made, making sure they come out the way you intended, if necessary, adjusting what you intended so that it works better, and getting them all made, getting all the bits to arrive, having all the right quality standards. So there's quite a lot of downstream work that goes on. But once you have your 3D design, it sets the scene for what happens after.
Have things changed in terms of three-dimensional drawings and plans? Has that changed in your lifetime? I mean, do you remember a time in your design world where it was paper and pen? Oh,
yeah, most definitely. One of the first jobs I had was working on a car called the Panther Solo. And the Panther Solo was a British-designed supercar, which was four-wheel drive and had a advanced composite structure and so on and so forth. And that was a project that was done in collaboration with a racing car company in Oxfordshire. And I was seconded to the racing car company, and my role as then, I can't remember what I was called, but basically I was responsible for the design of the body structure of the car and the aerodynamic testing. And I arrived at the office in this subcontractor's place, the design office, and I said, well, where is everybody? And they said, well, you're it at the moment. So there wasn't anybody else to help me. But what there was a drawing board. Some of your listeners might have to go and look up what a drawing board is. But essentially, it's a large flat surface with a thing on it called a dividing head, which had two rulers pointing in different directions that you could twizzle round. and a slidey thing across the top. But this drawing board was probably 20 metres long. It went, or at least 15 metres long. It went along the entire length of the office. And this is what they expected me to draw, full size, the car. In fact, actually in those days, cars were not drawn on drawing boards as such, but they were drawn on layout tables using film, which was treated so that you could draw on it and the pen would leave a mark, which had grids on every 100 millimeters. And there were lots and lots of people with things called splines, which were flexible pieces of plastic, and they would literally draw curves, project these things in 3 dimensions so that you could do sections and literally draw sections which described all these complex 3-dimensional shapes. It was incredibly labour intensive and time consuming.
Did you like the Panther Solo, and what happened to it?
The Panther Solo was quite an avant-garde car for its time. It employed the use of advanced composites, not just bucket and brush fiberglass, which was novel then. It was very fast and, at the time, very agile and very nice looking little car. But it's very difficult to get a car into production, and how much it costs you to build that car, how much you can sell it for and distribute it for, is part of the problem. And I think there were a handful made, maybe 20 or 30, I don't know exactly. You do still see them from time to time. But it wasn't a commercial success because I think it cost them more to build the car than they could sell it for. So the company eventually got sold to a larger Korean company, and that was the end of it.
And what does it feel like, Dan, when you've gone through all this process? I mean, I imagine when the car is made, it's almost like, the birth of a child, probably for you, because I'm sure you've gone through lots of ups and downs on the way. What does it feel like when you see that car that you've designed for the first time and you sit in it, drive in it and feel it?
It can be really exciting and actually moving at times. I remember the first time I drove the McLaren P1 at a test track in anger, and that was incredibly exciting after probably 3 years of working on it. I also remember driving that car again several years later against the next generation car that had more performance than the P1. It was the first time we had topped the performance of that car, and realised that it was time for the P1 to move aside and make way for the young pretender, as it were. So yeah, you do get very personally attached to the products. There's such a lot of great people working on the cars as well, and it's very much a collective effort. And so there's a strong sense of the team that delivered that and made it happen that's quite compelling as well.
You were chief designer on the P1. Tell us a bit about the P1.
Well, the P1 was the spiritual successor to the F1 in the sense that it was a car that was to be the ultimate road car and track car. So the best car in the world, which meant it had to be good on the road as well as the racetrack. And it was about trying to achieve something exceptional on road and track, so it had a great breadth of ability. And at that time, we debated what technologies should be employed in a car like that. It was about the time that hybrids were coming into the market, but hybrids at that point were things like Priuses, which were far from exciting.
I drove one. You're absolutely right.
Yeah.
Far from exciting.
Yeah. And the problem with hybrids then, and to some extent now, is the weight of the electric drive system. And so the idea of adding an electric drive system to a supercar was initially not very appealing because it had all the potential to make the car slower and not faster. So the challenge was to add the new technology, but actually enhance the car rather than do something detrimental to its performance. We set about developing our own systems and components that would actually be competitive with the existing state-of-the-art fuel-burning combustion components that were already in existence.
You're very humble about the way you slipped in there, sort of designing, the best car in the world. I mean, gosh, this is every little boy's dream, Dan, in many ways, which we will come on to in a minute. You mentioned the P1's hybrid. What was also quite special because when you changed gear, there was no lag because of the electric motor. Have I got that right?
Yeah, pretty much. So the interesting thing about electric drive systems is that electric motors make all of their torque or all of their sort of motive force instantly at zero speed, whereas a modern turbocharged engine has a thing called turbo lag. And turbo lag means that when you're accelerating from a low speed, especially in a low gear, you have to wait for the turbo to wind up because the turbo is spun up by exhaust gases. And until the exhaust gases have enough velocity, because the engine is going fast enough, it's not going fast enough to generate the boost, which generates the torque and therefore the power in the engine. So you have a mechanical system which inherently has this kind of lag characteristic. And if you then put that together with an electric machine, which has all of its torque at 0 speed, you have instant throttle response, which is obviously very much more appealing and is a characteristic of what you might call these days old school engines, which were so-called normally aspirated, no pressure charging involved.
What kept you awake at night on the P1, if anything?
Lots of things. Everything, really.
Go on.
Well, we were developing quite a lot of new things. We wanted the car to have this different characteristic so it could be fast on track and be great on the road, which meant it needed a new suspension system which could change height and change stiffness and characteristic for the track. We also wanted to employ active aerodynamics so that rather than just have a car that had a wing that went up when it went fast, it would alter the dynamics of the car in real time on a track, and that hadn't been done before either, really. And a new hybrid system. So there was quite a lot to keep us awake at night.
The P1 came with an eye-watering price tag. Who is a car like that aimed at?
The P1 is a kind of icon car for the brand, and a car like that is made in limited numbers and is sold to people who are collectors of specialist cars. Quite often, people who buy a car like the P1 have other similar iconic cars in their stable, in their collection. What we see is people drive them a lot to start with when they're quite new, and then as they become more collectible, they drive them less and less, and they then are thinking about the value of that car over the years, and hopefully it's going to appreciate for them.
And how did you feel when you drove the P1 for the first time?
Well, it was obviously, to say it was exciting is an understatement. Clearly it was exciting. I mean, it was the most exciting car I'd driven at the time. And I felt then genuinely lucky to be in the situation of being able to drive it and experiencing as a driver all the things that we tried to do when we designed it in the first place. The process it's a kind of growing process. So the car doesn't just work exactly the way it ultimately works straight out of the box. There's quite a lot of iterating and development that goes on. So it's difficult to pick a single moment when you have this astonishing feeling of, yes, this is it, it's done. But there is a point that you arrive at with every car where it suddenly seems like everything's fallen into place and the experience is just pure joy, and you're not picking, because constantly as vehicle designers and engineers, we are just looking at all the things that need to be fixed. That's not right, this isn't quite there yet, this needs trimming, that needs finishing, that sound needs fixing, this isn't the way we want it, we need more to enhance this, that, or the other characteristic more and more. So that's normal for engineers to think like that. You just think about improve. But there's a point where you have to shut the box and say, right, that's it, it's done now.
And when you shut the box and you're in it and you put your foot down, what would be the kind of top speed that you personally would drive that car at or experience?
Well, I'm not going to tell you that I've ever driven the car above the national speed limit.
No, I meant on the racetrack.
On a racetrack.
On private land. Because presumably, as the chief designer, you do have to feel, I would imagine, what the top speed feels like. Perhaps I'm wrong, am I?
I'm lucky enough that I do in my job get to assess these cars through to the end. There's a thing we call the jury panel, and I'm part of that process. So I do get to experience what the end user is going to experience before the car's sold and appreciate what they're going to appreciate. So I'm like a layman. We have professional drivers and test drivers who really push the envelope in terms of the finer points of calibrating electronic systems and this kind of thing. But in terms of the feel of the car, how engaging it is, how connected you feel with it. Yeah, I'm a part of that process. And having done several cars now, I do have a voice in how we tune the cars to make sure they have the right McLaren DNA and the right feel and the right engagement, because that's a really big part of McLaren.
You sidestepped that very nicely. In terms of your top speed, I'll get that out of you later off podcast. How do you Do you try and design racing tradition into a modern supercar too?
Yeah, that's a really good question, because there is a racing tradition. I think that's what I refer to as McLaren DNA. And if anyone has ever seen the McLaren Technical Centre, it's a beautiful building that is littered with historic racing cars. And you can see the history of McLaren racing in that building. But race car engineering design is all about lightweight, efficiency, aerodynamics, and vehicle dynamics. So those attributes are kind of core to what we try and put into the road cars. And to have as much of that DNA in the road car gives it authenticity, gives the product integrity. And when we get it right, and the whole design, including the way the car looks, is the byproduct of its attributes, whether it's the driving position or the aerodynamics or the dynamics of the car. When we get that right, then the car really has, the design has an authenticity and an integrity about it that will endure.
I mentioned earlier that your job title sounded every little boy's dream, and in many ways I think it probably was for you, wasn't it, Dan? I mean, tell us where your love of high-performance cars comes from.
I knew what I wanted to do from quite a young age, from being at school. Not exactly, but I kind of knew I wanted to design racing cars. I was interested in motorbikes as well, but I think probably on balance I was more interested in racing cars. And I didn't really know how to go about it. And I did discuss this with careers advisors who showed up at school, none of whom were very enlightening on the subject, I might say. One or two left me with some brochures for banking and the law, but I didn't really find that very stimulating. But I realised I needed to get an engineering degree, and beyond that, it was just going to be a matter of knocking on doors and persisting, really. But I did know what I wanted to do, yeah.
And how did you know what you wanted to do? I mean, were you inspired by mum or dad, or was anybody in your family involved in that world?
Nobody in my family was involved in that world. My dad was a master mariner who was a marine pilot on the Thames, and an enthusiastic but terribly bad DIY enthusiast. I always liked making things. My mum was probably the creative source, in the sense that, you know, she was quite artistic. She had been when she was younger, and although she didn't develop into a career for her, she had definite ability in that direction. So there was a creative thread in there somewhere, but I don't know where the interest in racing cars and all the things that go with it came from.
Did you watch racing a lot?
I watched it as a kid. I watched the Grand Prix on the telly, the sort of grainy reproduction with Murray Walker and James Hunt every time there was a Grand Prix. I think I was also influenced by the fact that you could hear Brands Hatch from the back garden of my parents' house. And so on a Sunday afternoon, I could hear this angry swarm of bees coming from the distance over the hills, which sort of drew me in like Toad of Toad Hall, I think.
You worked on the 2001 Arrows F1 team as well, didn't you?
Yeah, I worked at Arrows. It was a bit before 2001. It was in the late 90s.
Did you ever race yourself?
No, I've never raced competitively. I like driving fast on track. I'm reasonably consistent and smooth. I'm not ultra fast. And I do admire professional drivers who can do what I occasionally manage to do consistently, lap after lap after lap after lap, and modulate that according to however they need to. That is quite a skill, to be that precise and consistent.
I know that throughout your career you've worked a lot in the high-performance arena. You were also involved in the design of the Aston Martin Vanquish, weren't you? Was that an interesting time?
Yes. At that time, it was the concept car that we did for Aston Martin. We took the car to the motor show in Detroit that year and Geneva. It was a great opportunity because prior to that, Aston Martin used to make cars in a very traditional way. And the then chairman of Aston Martin, Bob Dover, sent me over to Newport Pagnell, where the old factory was, and to see what they were doing and then come back and report. So I went over to Newport Pagnell, and there were guys there in long brown overcoats with huge rasp files and big leather hammers working away, bashing sheet metal and putting sheet metal aluminium bodies onto what looked to me then like truck chassis. So I came back and told him what I had seen. And we had already designed and engineered a supercar for Jaguar called the Jaguar XJ220. And I said, look, I'm sure we can employ some of that technology and composite technology to move the game on for Aston Martin. That was embodied in the concept work we did for Aston Martin, which then subsequently became the next production version for Aston Martin.
And you have worked on cars for mere mortals like me. You were involved in the Volvo Convertible too, weren't you?
Yes, the slowest car I ever worked on. Volvo C70. That was also a very demanding project. It was a coupe and a convertible. It was the first convertible Volvo had done, and Volvo renowned for their safety. And so when we were at the stage of the project of defining what are the standards that are required for that car, it was a fairly straightforward conversation for Volvo in the sense that they said, well, we're going to build our first convertible. And we said, well, what are the rollover strength requirements you have for this car that's not going to have a roof? And they said, well, the same as the cars that we make today. So that was quite an engineering challenge at the time. And we had to employ some radically different manufacturing technology, some special steels, super high strength steel in the windscreen frame, and pop-up rollover devices to be able to meet the same rollover safety standards as they had with their production car with a roof on.
I'm fascinated, Dan, to know what you drive in your personal life. I'm guessing it's not a Prius from what you've said so far, or a Volvo Convertible.
I'm lucky, as I say, that I do get to drive McLaren supercars in my day job, but the car I drive now is a Toyota Aygo, which is actually quite a nice little car for London and very economical. It's got scratches on all four corners, so I don't mind too much if it gets bashed. And it's quite easy to park.
Well, easy to park is essential on small roads like this, where we are now. Also, McClaren was in the news, like a number of businesses were during COVID. You got involved in helping make ventilators, didn't you, at the beginning of the pandemic? What was that like?
Well, it was a very strange time after everybody had been sent home. So suddenly we found ourselves, like everybody else in the world, working from home and trying to connect via Teams and Zoom and so on and so forth. The UK government reached out to the race car industry, I suppose, and aerospace industry sectors, although not exclusively. There was also Ford Motor Company. And there was a hastily put together consortium called Ventilator Challenge UK, which employed a lot of well-known companies from aerospace and motorsport to massively ramp up the production of ventilators, which prior to that had just been built in extremely low numbers to kind of meet the needs, the perceived needs at the time for the hospitals to be able to handle the pandemic. We hastily put together a small team. We worked entirely remotely till it came to the point of building something. And it was extremely challenging. It was 24/7, but we all had a very clear goal, a common mission, and felt very strongly that we were doing something really useful at a time when it was very difficult for the company to do what it was there for, because the whole supply chain had pretty much stopped overnight due to factories around the world closing their doors.
It must have been quite humbling in a way, you know, when the country was struggling and in a mess in the beginning of all this, when we didn't know which way to turn, that a company like McClaren could actually get involved and do something that hopefully made a big difference at the time.
You know, we felt that we were doing something really useful and important, very stimulating and rewarding. A lot of different companies work together incredibly well and with this enormous sense of collective purpose, which is remarkable, which shows just what you can do, you know, when you need to. Put aside all the day-to-day politics and issues and barriers and just get on with it.
Professor Brian Cox said that this country doesn't have enough engineers because no one really knows what an engineer does. Engineering as a career, what would you say, Dan, to a young person who's considering it? Because to me, from the engineers I've interviewed throughout my career, it seems a fascinating career to have.
It is a fascinating career. It's a time now where there's never been so much change. Things happening so fast. Demands for even faster change. And as an engineer, you can change the future. You can change the way things are going to be. And if you decide you want to do something more altruistic than designing expensive cars, but something which is geared towards improving the lives of lots of people, engineering is the way to do it.
Talking of changing the world, I mean, in a world where we're faced with the climate change crisis, etc., how does the future look car-wise? I suppose what I'm wondering is, what will my 16-year-old and my 11-year-old be driving in the future? Are we all hybrid, electric? Where is it going, do you think?
There's clearly a big drive to zero emission. We're in the middle of that now. It's quite difficult to forecast exactly the products that we should be designing now for the next 5 to 10 years because things are changing so fast. There are cities who are looking at what kinds of restrictions to impose on vehicles in future to improve air quality. So you've got a local drive in terms of local air quality in cities for the health of people living there, and then you've got a global requirement in terms of reduced emissions. Sometimes those two requirements are not conflicting, but certainly not aligned, which means that it's not always easy to predict what to do next. In the long run, there's clearly a drive to see the back of fuel-burning technology in motive transport. Although batteries don't offer all of the answers, and there are lots of issues around the environmental impact of building batteries and electric motors, it's definitely part of the solution. The ultimate paradigm for some time has been seen as fuel cells, which are really cool things in the sense that if you can start with pure hydrogen, assuming that that hydrogen was generated in a sustainable way, the hydrogen is used as a fuel. The fuel cell converts hydrogen into electricity, which can then be used to drive electric motors. And the only byproduct is pure water. So it's clearly a very appealing model, but it requires a lot of change in terms of infrastructure, in terms of supply chain. There's still lots of challenges around how you store the hydrogen on the vehicle, but that would be a great answer. The other thing that's happening is autonomous driving. It's quite likely that, your children will be jumping into, Uber or similar, and there'll be no driver in the car.
That terrifies me.
They'll just jump in and they'll get to where they want to go, and then the driverless vehicle will take off and go pick somebody else up.
It's amazing, isn't it? In life, Dan, we don't often get a chance to reflect on our career or our journey. I mean, today we've had a bit of a stroll down memory lane for you. What do you feel most proud of as we've reminded you about different things you've done in your career?
I feel like I've been able to have a significant part in what's gone on at McLaren in the last 15 years, which has been a fantastic opportunity. You don't often get the chance to be part of growing a car company. Although I've done lots of interesting things before that, it probably felt when I joined McLaren as though a lot of those pieces made sense, which I could then apply to that role in McLaren. So I'll probably look back on my career and say that was the culmination of quite a lot of things that came together.
And what about the future? What's your next goal, or what's next for you, do you think?
I think that I can be productive and helpful in a mentoring role for some younger engineers. In a way, I'm surprised, but I understand objectively why it's good for younger engineers to listen to people like me, if only to have them see that they can do what they want if they really want it. I hope that I can sort of help to give them some sense that if they set their mind to it, they can do it. Maybe also I can give people the benefit of my experience if it's going to save them time in going down blind alleys and helping them to iterate towards the right solution sooner, or one that's probably going to work. But I have to make way for younger people coming through because, I can't go on blocking their career path forever.
I'm sure you're not blocking their career path. And just finally, when you're not designing or having a few sleepless nights over a new supercar, what do you do to chill? What's your idea of relaxation? How do you switch off from it all?
I like reading, but I'm interested in similar things to cars in the sense of I like architecture, I like product design, and I don't think I'm going to stop being inquisitive and wanting to design and make things. I think I'm going to keep doing that as long as I can stand, probably.
Well, I hope you're going to stand for a very long time. It's been really lovely to meet you at home today and find out more about what you do. I have to be honest, you were quite tricky to research, Dan, because there isn't much about you online. I think you're a little bit of an international man of mystery there at McLaren, but you've done some fantastic things in your career. And thanks ever so much for having us today. It's been really lovely.
Thank you. It's been really nice. Thanks.
You've been listening to Dan Parry-Williams, Director of Engineering Design for McLaren Automotive. Thanks very much for your company. I'll be back next week with another great guest. Don't forget you can download other podcasts at convex.podbean.com or search The Convex Conversation on Spotify and Apple and Google Podcasts and YouTube. Bye for now.